This is the second part of week 3, and in fact the third video of week 3. In this lecture, we define what do you mean by derivative or differentiation, same, and how the derivative and continuative are related. First, let's see what do you mean by derivative of a function graphically, or we can say visually. If you look at this graph, so this is the graph of the function y equal to fx, then I draw a secant line. Suppose if I'm finding the slope of this secant line, I'm finding the average rate of change. But if I'm finding the slope of the what you call the tangent line, then I'm finding the instantaneous rate of change. So look at it. The average rate of change is the slope of the secant line. The instantaneous rate of change is the slope of the tangent line at the point A. So the slope of the graph of the function at A, or the slope of the line tangent to the curve at A, is nothing but the derivative of a function at a point A. So in other words, I can just define the derivative or differentiation as the derivative of a function f at the point x is equal to a is denoted by f prime a. Please read this as f prime a, not f dash. Okay, so it is the limit of the same what we have discussed in the earlier lecture, that limit of the difference in y coordinate divided by difference in x coordinate. So h tending to 0. Okay, if the limit exists, then we say that f is differentiable at x is equal to a. So this is the value of x. So let's see an example here. Find the derivative of fx at x is equal to 1. I use this definition. See, f prime 1, because we are asked to find at 1. So a is 1 here. So I put 1 plus h, means this h is general one I will be finding here. So f1 plus h minus f1 by h. So f of 1 plus h I substitute here. So see that 3 times 1 plus h cube, that means x I am replacing by 1 plus h. 2 times 1 plus h, then minus 1, and then I put here x is equal to 1 here, then I will get these three. So I expand this, it will give me 4 terms, 1, 2, 3 and 4, and then I take 3 inside, and then I simplify this. You see, I will get this. So here h is common, I take it out and cancel, I will get 11 plus 9h plus 3h square. So then I will find the limit of this, but h tending to 0, there is no denominator, I put h equal to 0, I will get the answer as 11. So now I find the derivative of the same at unspecified value of x. So there we found the value of x equal to 1. Now I will first find the derivative at unspecified, that means not given, and then I will evaluate derivative at these 3 points. See that now what I will do here is a I will replace by with x in the earlier formula. Now this becomes x, see this becomes x. The earlier formula was derivative at x is equal to a. Now this is how you read derivative at any x, that means all x, any x value. So I substitute the same thing, I substitute now x as x plus h. So instead of a, now I have h. I simplify all, sorry, instead of a we have x, I simplify, and then this will give me 4 terms. I have 4 terms. I take 3 inside, and be careful, this minus is goes to this 3 term, and I simplify. Then we have a h common, we cancel it, we get this. Then now look at it, I am finding the limit of this as h tending to 0 means I will put h equal to 0. I will not disturb x. So therefore, this is 0, this is 0, the 9x square as it is. So this is 0, this is 0, the limit of constant is constant. So this is what the derivative of fx at all x values. So now I will put x is equal to 1. See, I will put x is equal to 1. So f prime 1. Now I put x is equal to 1. I will get 11. Then I put x is equal to 2. Then I will get 38. X is equal to 3. I get 83. That means this is just like we did the earlier example 11. In example 2.1 also we get the 11. So this is an example of finding the derivative at all values of x and then substituting. So the derivative of a function is denoted by f prime, it is f prime x. So here I am defining the derivative of every value, all values of x. So I'm just replacing a by x. So this is the derivative of a function at all values of x. So here uh, the process of computing a derivative is known as differentiation. The process, the method or the steps of finding the derivative is known as differentiation. Of course, we use differentiation derivative alternately, both meaning the same. If f is differentiable on an open interval I, and then if it is differentiable at every point on I, that means interval here. So look at it. Ultimately, the value of the derivative function at a point is the slope of the tangent line at that point. So this m tan is nothing but the derivative. It is also known as slope of the tangent line at that point. So if the derivative is negative, that means if the slope of the tangent is negative, then the slope is like this and the graph is decreasing. If the slope or the derivative is 0, then the tangent line is parallel to the x-axis. That means it is neither increasing nor decreasing. If the slope is positive or if the derivative is positive, then the tangent line like this, then the curve is increasing. Curve decreasing, positive, negative. Curve neither decreasing nor increasing, 0. And curve increasing, the tangent or the derivative will be positive. So these are the alternate what you call notation for the derivative. This is the function given y equal to fx, and we can write f prime x is nothing but the derivative. Y prime, just we write y prime, it is also derivative. Sometime we write as dy by dx. Check here, dy by dx, same. Df by dx, same. D of fx by dx. So look at it, these are all alternative, what you call alternative derivative symbols or notation. And lastly, very important, it's a very important theorem that if f is differentiable at this point, then it must be continuous at that point. That means if a function is differentiable at a particular point, then the same function is continuous at that point. Let's see one example here. Show that fx given by two function is not differentiable at x is equal to 2. So what I will do now, I will find when two functions are given, to find the limit, I need to find right and the left limit. I find the right limit. I put what you call at x is equal to 2. That means a is 2 here. I substitute, then f of 2 plus h. So since h is greater than 0, so greater than 0 means I will be using here what you call, I mean, this value here. I mean, the two values here. So limit of, I just put 2 times. That means I'm using the second value here if it is a greater value. So I will substitute here 2 times 2 plus x. That is the second values here I put. So look at it. I just substitute. I get 2 times 2 this and this value. And then h cancels. You get 2. That is right limit is equal to 2. When h is less than 0, that is 2 plus h is less than 2. Please remember here, when h is greater than 0, 2 plus h is greater than 2. That means here we are. When h is negative, then 2 plus h is what you call less than 2. So therefore, f of 2 plus h is equal to 4. So for right limit, I will use the second function. For the left limit, I will use the first function. So f of 2h minus f2 by h. F of 2 plus h is what? 4, which is the first. Then f2 is 4, right? Divide by this. So 0 by h is 0. So limit is 0. So right limit is 2 and the left limit is 0. Left limit exist, but they are not equal. Therefore, f prime 2 does not exist. That means I say that f is not differentiable at x is equal to 2. So these are the examples. Look at it. F prime a, that is the derivative at x is equal to a, does not exist, meaning f is not continuous at that particular point. You see, there is the value of, as per the definition of continuity, the function is discontinuous at a, again discontinuous at a, again discontinuous at a, discontinuous at a, and also there is no function, I mean there is no derivative, or means derivative does not exist at x is equal to a. Look at it, these are the 4 graphs where the derivative does not exist, and it is also not continuous at a. So these are the examples, and you are asked to find find f prime a for these, right, at particular values here. And here we are asked to find the compute the derivative of this, and again this. Look at it. Here we are finding the derivative at all point. This is the derivative at one particular point. So I will do these. So one example from 1 to 4 and 5 to 8 in the live class. So what we studied in this, we studied what do you mean by derivative? That is visually, the graphically, what do you mean? And what is exactly the derivative definition? And how to find the derivative at a point and at any point, that is at x, and how the derivative continuity are related, right? So that's the end of the third video of week 3. Okay, so the more example or the exercises whatever I have given in these 3 video lectures of week 3, so those what you call examples I will take up in the live class. uh, I will go in accordingly. What you call, I finished first the week number 2. There are some examples we couldn't do in the week 2. So I will take that first. Then I'll see in sequence, I will cover all the exercises which is given in the video. Thank you.